All right, so on Classroom, please download or look at whatever you want to do. Facts and theorems. What's that? I'm gonna it's gonna take a while, but at the very end, before I end class today, we're gonna go over a review problem, but not until then. Okay, not until then. Everything's gonna be off of this facts and theorems sheet. All right, ready to roll. Okay, I already told you it's days 4 through 9. Nothing before that. Nothing on quiz 1. All right, let's go. Get ready here. I'm going over every single thing I could remember, right? Every little thing starting from day 4 all the way on. So first thing I'm going to ask somebody here, hey, angle A, what's it called? How do you find it? All right, I want you to know where you need to be before you leave the room today. All right, Monday when you walk in, I need to know all of this. Angle A, what type of angle is it and how do I find it? Nothing? Oh, there we go. We're ready to go. All right, what type of angle is it up here? Here we go. Will, what type of angle is it? Inscribed. How do you find angle A? Using the letters I've given you on this circle. Half of arc CB. Good start. Way to get off on the right foot. Okay, that's an inscribed angle. Half its arc measure. All right, moving on. Top right-hand corner. What do I know about angle J? All right, I'm not looking for Y. I want to know, what do I know about angle J? What would you put on my diagram here? All right, what do you know about angle J? Next up, Zoe, do you know angle J? It's okay if you don't, because I know you haven't. What's that?
It goes to the center, but is it the?
It's all right. It's all right, because you missed a bunch, so I wouldn't expect. All right, then let's go to Aiden. What do you know about that angle?
It's 90 degrees.
It's a right angle. Okay, that's a right angle right there. Now, it's very likely maybe you put that on a proof, the diagram I gave you on Monday in the proof. Why? What would be your reason now you put a right angle there? All right, what would be the reason you put that right angle there? Ian, what type of angle is it?
Inscribed.
Here we go, everyone. Inscribed angle. Drawn to. Where's it drawn to in?
One of those, like a secant or a chord. A chord.
This is the center.
Angle J.
Yeah.
Yeah, aren't those two chords?
It's drawn angle. Here's angle J.
Oh, like a cross.
Yeah.
Like
Where's it?
diameter.
There you go.
I don't know that.
You're good. Inscribed angle drawn to a diameter is a right angle. Okay, that's what I would expect in the reasons column if you had to put a right angle on your diagram. Might be a right angle for another reason, which we'll get to later on down the line here. Next up, bottom left-hand corner of that page. Tell me something about those angles. And I don't want to hear vertical angles are congruent. I want to use circle facts here. All right, so other than the vertical angles being congruent, any relationship between A, B, C, D. Angles A, B, C, and D. Give me something that's true about my diagram other than vertical angles are congruent. Anything you see up there between A, B, C, and D? Zoe, you want to take this one? You're good.
Share the same arc.
Oh, that means they are? There you go. Perfect. There you go. We got one now. So I could say angle A congruent to angle B, or I could say angle C congruent to angle D. Both are true because of inscribed angles. And Zoe already said this, so I'm not going to call on somebody. Inscribed angles drawn to the same arc are congruent. Inscribed angles drawn to the same arc are congruent. And finally, bottom right. What's the relationship between some of those angles? This one's a tough one. This has been getting kids today, this one. Don't tell me all 4 add up to 360. I know that. I'm looking for a circle fact. There's some relationship between some of those angles up there. What is it? Anything for me here? Anything? Where are we going? Doyle, anything?
Angle G is congruent to angle I.
Not congruent. There is a relationship, but they're not. There is a relationship.
Oh,
But
supplemental.
yes. Opposite angles in an inscribed quadrilateral are supplementary, and I just put congruent. Are supplementary. All right. I'm not going to write the theorem because I can tell you I'm not going to need the theorem, but I am going to need you to know that those are supplementary. All right. We good here on these four? That's just a sniff too. We got more to go, as you can see. Here we go. Let's keep grinding. Next diagram. What do you want to add to it? Top left. What do you want to add to it? Jenna, these are all on Classroom. All right. What we're doing right now. Facts and theorems, it's called. What do you want to add to this diagram? Add something to it. Add something to it. Ooh, Amy, add something to it. What do you want me to add to it? Darn right. We should have a right angle right here. Very common that you put that in the proof. All right, that's a right angle. Why is it a right angle? Amy, going back to you. What's the green line up here? Radius is drawn to the, what's that green point, Amy? There you go. Good work. To the point of tangency forms a right angle. So that's a second way you could get a right angle in a circle. Inscribed angle drawn to a diameter, and now radius drawn to a point of tangency. A lot of my classes today are struggling with this one here. What's so true about this diagram? All right, it's been a while since we talked about it, but we did talk about it. Same day we did radius drawn to a point of tangency. All right, a lot of classes struggling with this one. What was true about this diagram? And G, K, and I, that's where these touch the circle. All right, that's where they touch them. Do we remember anything about this? What's true about this diagram? John, you get your thing set up there. I'll get back to you. Olivia, remember anything that's true? Good job. Awesome. FG congruent to FK. In addition to that, we also have GH congruent to HI and also IJ congruent to KJ. Perfect. Reason? Maybe you'll use this in a proof. Not the Partiat theorem. You write down the Partiat theorem, I will hunt you down in your next period class and come right in and embarrass you. You write Partiat theorem. Tangent segments, because they're not full tangents, remember, they're just part of one. Tangent segments drawn to. Notice anything about where all these congruent pieces are drawn to? What?
Same point.
Oh.
Well, I guess they are drawn to, not the same point of tangent. They are drawn to point of tangent. You got it there, yeah. But each of them's drawn to, on the other end, the same point. Drawn to the same point are congruent. Before I leave this one, I just don't want you guys to think this only applies to the diagram that looks like this when I have a circle and a triangle drawn circumscribed around it. No. Hey, it could be just as simple as this. Still applies. Those two are congruent. So I just don't want you to think, oh, I got to see a circle with a triangle around. No. It could just be as simple as that, and it still applies. All good? How do we feel so far? A lot, huh? You know what I haven't even talked about yet? All those angles now, inside, outside tweeners. Haven't even talked about those yet. Yeah, it's been a lot. It's going to get more than that. It's going to go more. Get crazy. All right, next up. Here we go. If the angle is inside, it's one of three types, right? One of three types. Let's talk about angle KPN. What's it called? How do you find it? Okay, this is one type of angle that can be located inside a circle. KPN, what's it called, and how do we find it? Steve, what's it called? Floater. How do you find it? Using the letters from this circle.
Arc NK plus arc LM divided by 2.
Good job. Its arc that's connected to NK plus I look at the vertical angle to that floater and look at its connected arc, LM, and divide it by 2. Make sure it's plus. Plus, don't get confused with subtracting. That's coming up. Next one, what type of, I know we have done this already. Repetition is good though. Stop whining. Angle A, what's it called and how do I find it? Whoa, that was, John, are you ready to go? All right, what type of angle is that? How do you find it using the letters on the circle here?
It's half the CB.
Which one, half of?
CB.
Yep, you got it. Good work. Half a CB, excellent. Well, if it's not floater or inscribed, it probably is our last type, and I apologize here. You can, that's circle O. I should have put an O there. One job. If it's not floater or inscribed, it'll be, what type of angles? ROS here. ROS. Aiden, over to you.
Central.
Central, how do you find it?
Congruent to RS.
Darn right. Machine over there. So those are the 3 types you could find inside. If it's not inside, it could be outside. And then no discussion. There's only one example. If the darn angle's on the outside, look, this is 2 secants, right? It could be 2 tangents. Could be a secant and a tangent. Doesn't matter though to us. Doesn't matter. It's found the same way every single time. If the angle's on the outside, here we go. How do I find it? Using the letters in this circle. Boom! Gianna, going back to you.
Take the 2 arcs.
Yep.
Subtract them.
Okay, I got 4 of them up here. Which 2 do you want me to subtract?
US minus 2
Unbelievable. And then do what? Sorry, I cut you off.
divided by 2.
Whew. Fire. If it's not inside, if it's not outside, let's hope it's a half and half. As we know, tweener. 2 types of tweeners. We talked about them on homework, but we'll do them again. First tweener angle is XWV. Right there, XWV. This is a tweener angle formed by, hello Gabby. Ready? What's XW up there?
A chord.
Yep, and how about VWY?
A tangent.
Okay, so this is a tweener formed by a chord and a tangent. We got a rule. Chord and tangent, we got a rule. You know that rule?
Isn't it like a chord in between, like, isn't it divided by 2?
Something's divided by 2, yep.
The chord in between angle.
I don't think you mean chord. I think
Or
you mean...
the arc.
There you go. I saw your finger. Yep. So what arc am I going to divide by 2?
X is double.
Good job. You got it. I'm going to take half of the arc in between. Good job, Gabby. Chord and tangent, tweener angle, we got a rule. Chord and secant, we went over on homework, so I'm not going to ask anybody. Angle ABC, chord and a secant, no rule, right? That's the tweener angle that has no rule. But how did we find it on homework? Find the inscribed angle next to it, subtract it from 180. So those are all inside, outside, all the tweener stuff you could see. And there's still more. There's still more. Here's some additional ones that you might use on Monday. So I didn't need a diagram for it like the others. Remember, if you have congruent arcs, if 2 arcs are found to be congruent, whether it be given or you find them, the arcs to be congruent, that means any central angles drawn to them are congruent. Any inscribed angles drawn to them are congruent, and any chords are congruent, right, that make up that arc. Right? So just, if the arcs are congruent, you got some power there. We went over this one. It was before break, but if you have 2 chords equidistant from the center, they are congruent, right? If they're the same distance from the center, those chords will be congruent to each other. I did decide to do a diagram for the 4th extra fact. I just wanted to see if you guys knew what was happening. What's happening in that diagram based on what I drew up there. And yes, that red dot is the center. what is happening in that chord that you could either mark on. What is happening in that diagram. Hopefully nobody heard that. What's happening in that diagram? Oh, here we go. Haley, hello. What's happening?
It's getting bisected.
What's getting bisected?
The cord.
Thank you. The chord is getting bisected because of the theorem. Diameter perpendicular to a chord bisects the chord. So we're clear again. If you use this in the reasons column on Monday of your proof, if you happen to use this, your statement shouldn't be DE congruent to EB. If you're using this in the reasons column, your statement is DB is being bisected by chord AC. Now you could say the step after DE equals EB, definition of bisects. Definition of bisects. Okay, but this is only to say the chord is getting bisected. Wow, we're finally done. I have one more little thing to do with you, but that's it on circles. All the facts you need for Monday. All. And I did my best. Mrs. Linehan, the other honors geometry teacher, and I did our best to put as many of these facts in as we could. All right, whether it be in the proof, in a king size circle problem, or any of the algebra problems you'll do. Okay, we did our best to make sure all these facts are used. Last thing, and it's not a geometry, it's not a circle thing, it's an algebra. This will come up, I'm not going to tell you how it's going to come up, but it's going to come up. You're going to set up an equation, and part of that equation is going to be something that looks like this, a quantity all squared, and I want to make sure you're solid there. All right, because the last thing I want to see is you know your circle facts down pat, you wrote a beautiful equation, and then you just butchered how to do this. All right, that's not what I want to see here. All right, how do I deal with this? So this comes up, I'm not going to tell you how it's going to come up, but you write down, you're writing, you're up, I got to solve this, now how do I do this? No, I may hunt you down next period if you do that. Rewrite it twice, and we're double distributing, right? Double distributing. And then distribute the -3. Be careful there, +9. Got some colors working here today. All right, it'll come up. Just want to make sure you're aware of it. All right, I am done on Google Classroom. Don't shut them down though. Can you go back to Unit 10 on Google Classroom? I just want to make sure you're aware of something I posted there a while ago. Can you go back to Unit 10 on Classroom for me? I posted king size circle problems for any of you that want. There's some in your packet, and then I posted some here. Don't be intimidated. I posted 46 of them. Okay, there's 46 king size circle problems on Classroom for you to practice. The answer key is after the 46th problem. All right, so the answer key to that is on after the 46th. Okay, I wanted to give you plenty to try out this weekend if you wanted to. As a class, you're going to be working on number 7 right now in your packet. So day 10, number 7. So you can close up the Chromebooks. We're done for now with those. Number 7 in the review on day 10. I think I picked the most challenging king size circle problem here. What's up, Matt?
We need to know the quiz 1 stuff.
No, don't waste your, Matt, do you see how much we just went over?
Yeah.
Yeah, that was a ton. I don't think we need more. All right, nothing, no circumference, arc length, none of that. Radians, none of that. You will not sniff it. All right, you worry about days 4 through 9. That's your focus for Monday, days 4 through 9. All right, go ahead, take a look at number 7, start labeling all the givens. I thought this was the most challenging of all the king size ones on there. It's not straightforward at all. This one, we got to think outside the box or outside the circle. Everyone's got them labeled or getting them labeled? All right. For some of you that are looking at A through E, I don't know what you're doing. Stop. We don't start there. King size circle problems. We start by finding all the arcs first. Find all the arcs. And I get it. There have been times where we couldn't find every single arc, but most of the time we can. And this one we can. So can anybody, I have 2 out of the 4 arcs I need. 2 out of the 4 were given. Can anybody find another one here for me? Based on everything else I've given in this problem. Anybody know another arc measure up here based on this info? And you know your rules. Anybody want to take a jump at it? Doyle, go ahead, boss. What do you got?
Arc EA is 75 degrees.
Why do you say it's 75?
Because angle EA is 75 degrees.
So you're saying because that's 75, it's equal to its arc, right?
37.5.
Okay. You're going in the wrong direction. Ready? Here you go, Doyle. Ready? Everybody, 75 degrees. You see what you did?
Yes.
Okay, hold on. I'll get back to you. You can redeem yourself from that embarrassing moment. 75 degrees. Isn't that a tweener angle? I'll jump right to it. It's a tweener, right? How's it formed? EA is a what? Chord. BAF is a tangent. Oh, we have a rule for that. So 75 degrees was found by taking half the arc, right? I don't take half of 75. What do I do, Doyle? You double it instead. Yes. So that's how I know this arc is 150 degrees. Because 75 is a tweener formed by a chord and a tangent. And now I have one more arc. And guys, hey, if you tell me you have one more arc you're missing, there should be no excuse why you can't find that. They all add up to 360. Right? So no excuse why you can't find one more arc. And I believe that's 70 degrees, everyone that's finding it. All right, you ready? Everyone's going to help me out here. I don't need any help with arc AE, though. We just found that, 150. All right, now I'm going to need help. Ready? Angle DOC, inside, outside tweener. Angle DOC, what are we looking at there? Haley, going back to you.
Central.
Central, she even jumped the gun there. Good, we went right to it. Central angle. How do you find a central angle?
The arc measure.
And what's the arc measure?
7.
Done. Not bad when you know your facts. Also, remember, label it. You never know, might need it coming up. 70 degrees. All right, here's where it gets nuts now. OAB, angle OAB. Everyone take a look. Angle OAB. I know angle OAB looks like a tweener, doesn't it? Because half of it's inside, half of it's outside, but it's not a tweener angle. Because what's OA? Radius, I need a chord, right? Chord tangent, chord secant to be a tweener. Not radius tangent, that doesn't work. So unfortunately, I better know something else because it's not a circle. It's not one of those angles we've talked about. It's not central, inscribed, tweener, nothing. We don't have a name for this type of angle. So I'm going to need to rely on something else. What else do you notice or what else you want to tell me here? Because we can still get to it. Oh my God, Haley, this is 3 for 3.
Is it 90?
You tell me. Yeah, it's 90. What's ready? What's OA?
Radius.
What's point A?
Point of tendency.
Okay. When those two meet, we form a right angle. That's how I get to it. I don't need a rule. I need a fact. Oh, now it's going to get nuts. If you weren't comfortable with part C, you're definitely not going to be comfortable with D. OAE. Can I ask you guys a question so I feel more comfortable going into Monday? Is OAE inscribed? No. Remember, inscribed, they both have to be chords on each side. AE is good, but OA, no. So again, another type of angle I don't have a name for, which means I don't have a rule for. But I think we got some geometry in our back pocket that would help us out here. Talk me through this one. OAE. Do we go 4 for 4? Oh, no. Zeev, talk me through it.
it right angle?
Yep, all right, AF?
Oh, yeah.
OAF, got you, yep, that's gotta be a right angle right next to it, so.
90 minus 75.
Yep.
Is 15.
Did anybody do 90, the missing angle, and 75 add up to 180? Straight line, perfect. Straight angles equal $1.80. That's the other way around it. Ooh, and then we get to the tough one, DCO. Yikes, DCO. Inscribe? Central? Nope. Not a floater. We don't have a name for this one either. We do not. This is why I picked it. We do not have a name for that, so that means I can't tell you how to find it. Keep looking. Keep looking. DCO. How do I find it? It's not supplementary to anything either. Well, I guess it is, but I'm not going to find that angle it's supplementary to. Anybody see anything on this diagram that lead me to DCO? Aiden, what's good?
DO and CO are radii.
Stop there. He's correct, which means they're what then? If they're both radii in the same circle, that must mean they are. Go ahead, Aiden, sure. Somebody else is helping me out. They are congruent. And what did you just reveal there, Aiden, about this triangle? There you go. Across from the congruent sides are congruent angles. Good work. Good work. 180 minus that 70, divided up into two congruent angles. 55. Last thing, can you go to the answer key on page 44? Because there is a mistake. I know, even the great ones make mistakes. Page 44, answer key to the review packet. We made a mistake on number 14. We made a mistake on number 14. You can cross it all out. Don't think you have to use, I know people are like law of cosines. Don't worry about it. Cross it out. You don't have to use any of that. Okay, we changed the problem, but didn't change the answer to it. The answer to the problem is 4 radical 10. All right, so number 14, 4 radical 10, and no, you do not have to use law of cosines or inverse trig. It's a lot easier than that. All right, we changed the problem, but forgot to change the answer key. All right, choose your own adventure. You got 46 king-size problems on Classroom, and you got a bunch in your packet with an answer key on page 44. You can move around and work with whoever you want. Your call.